Welcome to the Defense and Aerospace Report. I'm Vago Muradian here at the Aberdeen Proving Grounds in Maryland, where we are participating in Stryker Lethality Day, an opportunity for the media to see the brand new 30mm gun version of the Stryker, as well as the Stryker family of vehicles, and the version that's been equipped with the Javelin, which is the Crow J, the Crew Remote Operated Weapons System, which isn't a mouthful, thankfully, Javelin variant. And we have the man who's made this and his team who's made it all possible, Colonel Glenn Dean, who is the project manager for the Stryker family of vehicles. And if that wasn't enough, the largest family of combat vehicles that the Army has, you're also the active protection guy for the Army and are in the middle of that, and also dealing with lasers as well. So you have a lot of spare time on your hands. Colonel, talk to us a little bit about the importance of what you guys were trying to achieve with this program. The 30mm version, 2nd Cavalry Regiment in Europe made that a top priority. General Hodges talked about it, and in about 25 months you guys have brought this system and are fielding it. Where does this fit into, and talk to us also about the Crow's J, and how these two new systems fit into the family of lethality when it comes to Stryker, given that you already have a 105mm soft recoil. The mobile gun version is already deployed.
Right, so let me start with some context, right? So the Stryker is our medium weight brigade. It's an infantry formation. It's designed to move infantry very rapidly over operational distances, as we've seen in Europe, right? They deploy by road from their garrison in Vilseck, Germany, to the eastern frontier, NATO, Baltics, Romania. They're in Georgia right now. And so how do you retain that capability? Over the past years, we've been growing survivability of the Stryker formation. So we rolled out the double V hull, which was an IED mine protection, new design vehicle. And when we did so, we gained a lot of weight, we lost some mobility. We immediately went into how do I recover that mobility? We're delivering a DVH double V hull upgrade today. First vehicle rolls off the production line this month. That restores all that mobility, bigger engine, more power generation to that family. But it is a family of systems that have to come together to deliver capability. So you've got infantry carriers that are delivering the infantry and supporting them in combat. The squads are the primary weapon system of the formation. But you have to command them, you have to medically evacuate them, you have to provide fire support and mortar support and direct fire support. To reduce those kinds of targets that are either threats to the infantry or that are more difficult for them to defeat with their manually carried weapons. And that's partly the genesis for the lethality program that we're now executing, is how do I bring more lethality to the formation as a whole? And it's not really just about the vehicle. The vehicle is an enabler, and so it's not a single vehicle program. Now, of course, the sort of most visible element of what we're doing is this vehicle, the infantry carrier vehicle, Dragoon, which is the 30mm cannon vehicle.
Which, by the way, is a great name for the vehicle.
Well, and appropriate because it's going to the Army's oldest regiment, the 2nd Regiment of Dragoons. And, in fact, it's a long rifle for the Dragoons. And for the folks who don't know the history of that name, right, we used to have cavalry who fight mounted and infantry who fight dismounted. And then there was this little sliver of guys that would ride to the battle but then dismount and fight on foot, Dragoons. And that's what Stryker units do today, so it's very appropriate that 2nd Cav is getting this capability as the Dragoon Regiment. So the requirement was better support the infantry, allow them to dismount farther away, allow them to defend themselves against more threatening targets. We do have the mobile gun system in the formation. It's principally an infantry support weapon, an assault gun, if you will. It's there to reduce bunkers and fortifications, breach walls. Yes, it has some anti-tank capability. It's a 105mm main gun, of course. But its principal mission is really more in that fortification range, and we only have 12 of them in each brigade. So the 30mm capability was really there to support all of the infantry and all of the cavalry. So for 2nd Cavalry Regiment, we got an urgent requirement in 2015. We were funded by an appropriation, some money was moved right at the end of 2015 to start the activity. Now, we were lucky that a lot of the elements that needed to come together to make this vehicle had kind of been in the works in various places in the DoD for a while. So the cannon is actually an evolution of work that started in the Navy, went on in the Marine Corps, and was part of the Army Future Combat System and ground combat vehicle programs before that was terminated. None of those ever made it to the field, but we were able to pick up from where they left off. The vehicle itself, we're using a flat bottom vehicle in the inventory. But because the turret adds a bunch of weight, we had to upweight the suspension. So we took the suspension from our double V hull. So that was something relatively mature. We ran a competition through our prime contractor to select the turret, and the driver for that was, can it be ready and fully mature in the schedule we needed? And that's how we ended up with this Kongsberg medium caliber remote weapon station. So by selecting things that were mature, focusing the requirement down very narrowly on the critical capabilities, and understanding the operating concept we were working from, which is I can't give up any infantry on this platform. So this vehicle still carries the 11 soldiers it was originally designed to do, and has to take on the turret and the cannon as well. We were able to do that because we were relying on things that were mature.
Tell us a little bit about Crow's-J and how that fits into the increased lethality plan for Stryker.
Okay, good. So interesting, because before the 30 millimeter requirement arose, allowing the infantry formation to use its Javelin from under armor, where they're protected, was their top lethality priority. 30 millimeter kind of took center stage, but we were given authority when we started the program that if we found any savings in the program, we could reapply it against Stryker lethality initiatives. And there had been work done to integrate the Javelin on the common remote operated weapons station. That's the standard Army remote weapon station. It's actually slightly different than what we have on Stryker today. They're virtually identical, but not interchangeable. But one happens to be Army supported. So we were already looking at it as a replacement for our current RWS to address some obsolescence and get to a cheaper operating cost. And because two of my sister programs had integrated their products, Javelin and the Crows, when we had a little extra money that we could peel out of the ICVD program, we realized that we could deliver that capability at the same time as the 30 millimeter vehicle. And so what we're really doing is we're presenting the commander with options, right? So now he can fight that vehicle mounted, rapidly dismount an anti-armor ambush, or fight his anti-tank missiles dismounted, or use them in conjunction. And so the ability to kind of work around the edges with some savings and deliver multiple capabilities simultaneously is really exciting for us.
What were some of the big trade-offs you guys had to make in order to be able to drive this capability? I mean, 25 months, we talked to General Bassett about this, 25 months is an extremely aggressive schedule. Even if you've got everything in the parts bin, as you did design-wise, you still have to type qualify stuff, you still have to put it all together, you have to integrate it, you have to design it. The supply base has to respond in order to be able to get the components, whether from raw materials to finished product. Talk to us a little bit about what were some of the trade-offs and the hurdles you guys had to overcome in order to drive this kind of schedule, because it was what, 15 months from money to prototype?
Right, yeah, 15 months until the first prototype actually showed up in government hands and we started test. So yeah, first is about requirements trades. So when we got the initial requirement, there were actually things that would have been infeasible. Right, there were some really technically demanding requirements that required technology that we did not have, and so the Army made some deliberate decisions to narrow that requirement to match those things we were likely to get with mature technology. And then we prioritized them and said, hey, there's only a couple of must-haves. You know, you must meet a timeline, so that was our driving schedule. You must deliver a certain level of lethality, and you must retain a 9-soldier squad and a 2-soldier crew on the platform. Everything else was trade space. And that gave us tremendous power to be able to select among available options. It was also very powerful to have our end user, the specific unit we're going to field to, as part of the process. So 2nd Cavalry Regiment actually came in early in the design process and made some of the technical trade-offs for us. We said, okay, all the turrets are big. We hadn't selected a turret at that point, but we said, we know we're going to lose 2 hatches on the top of the vehicle. Which hatches are you willing to sacrifice? Where do you want the vehicle commander positioned? Right now he's on the right side of the vehicle, but we can move him to the left, we can put him someplace else. What do you want? So 2nd Cav gave us a couple of very clear early decisions. Keep the commander where he's at. We value the 2 rear hatches, what we call the air guard hatches, over the forward hatches. So we said, okay, we'll put the turret forward. That helped us from an automotive design perspective. We relocated the squad leader's hatch on the vehicle a little bit forward, and they told us how they'd prefer that hatch to operate. And so that helped narrow a bunch of early design decisions. There's nothing more powerful than having the sort of final end user part and parcel of that decision process. But then you had to live with the trade-offs you got. So the turret we got was what was mature on the time frame we have. And so depending on what your opinions or desirements are about what your turret does, you may have different opinions about the design. So we did get a linkless feed turret. That's a very reliable feed system. So that's a positive. We were asked early on, hey, am I going to get a coaxial machine gun? And the answer was, that's actually not in the requirement. So maybe if the turret that's bid has it, we'll go ahead and latch onto it. We're not going to turn that capability down. It just so happens we did get a coaxial machine gun, but that's actually one of our challenges right now. It's an externally mounted, it's externally loaded, and we've had some problems with the orientation of the feed chutes, and so there's been a little bit of feeding problems with that gun, and so we have a technical challenge we're working through. There's been concerns about visibility on the vehicle. There are no external hatches that the soldiers can use to look out of the turret, right? That helps with driving and orientation. We have improved the size of the commander's periscopes, the squad leader's hatches there, but still there's some concerns about driving visibility. So we're still exploring, hey, if I change the field of view of my driver's vision enhancement, maybe to add some other cameras, is that something that can balance this out? Access to the turret to reload under armor, to clear stoppages for the cannon, if you have any, that was a concern. We do have a manually accessible turret. There's a manual backup system. You can traverse and fire the gun without power, but it's really awkward to use, and it's not something that anybody would want to use on a regular basis. And so, yeah, if you were going back and designing from scratch, those are things you might choose to design around, design out, or maybe once you learn from this, maybe those aren't as important. But those are the sorts of trades we have to go through.
Every vehicle, every program is a trade-off. People have a tendency of thinking that armored vehicles, you sort of get an unlimited tableau, but you don't. It's actually incredible design constraints. It's almost airplane-like in its design constraints, whether for cooling of the engine, given that all of this stuff has got to be armored and under some form of protection. Talk to us a little bit about the added weight that this puts. It's about 5,000 pounds. It's a steel turret, which will relax some folks. But it's weight that's set pretty high up in the vehicle. It's a relatively narrow and tall vehicle as it is. So what are some of the design challenges you guys have faced with it? For example, do you have full traverse mobility, fire capability, for example, with the turret, which is something with the mobile gun system is a little bit constrained when you're firing at a 90-degree angle to the vehicle. It gets a sporty degree of lean, and let's put it that way.
Yeah, so let me address that first, because there is a myth that you can't fire the MGS 90 degrees over the side. Absolutely a myth. It can fire in its full range of traverse and operation. It may look bad if you're on the outside, but trust me, it's fine. Yeah, adding 5,000 pounds to the vehicle, especially when it's to the top, right? If you're going to add weight, you'd rather add it low, where you're not going to influence the center of gravity, where you're going to tip more. There's a risk of rolling over. That was kind of a known constraint, right? And it's tall. This vehicle can't load on a C-130. It's too tall. It can load on a C-17. Luckily, we didn't have a C-130 requirement for the platform. We were able to mitigate some of the concerns about stability with going to wider tires. That also had the benefit of offsetting some of the soft soil mobility impacts that you get when you go up in weight. So this vehicle, both in weight and mobility, is about the same weight as a mobile gun system. It's got a little bit better mobility, though, because the wider tires and the heavier duty suspension help it carry that weight a little bit better. But still, in a perfect world, I would have up-engined it as well. It's 5,000 pounds plus against 350 horsepower. Not as good a trade as my double V hull, which now has a 450 horse engine. It starts 5,000 pounds heavier, but it's got thousands of pounds of margin before you find the impact of that weight, and that's with all its combat kits.
Talk to us about what's next in the Stryker pipeline. You guys are constantly upgrading and giving better capability to the vehicles. What is in the pipeline? So in the next 5 years, what are your priorities?
Yeah, so the near term is get this lethality capability out to 2CR, and that's actually 3 capabilities. It's the infantry carrier vehicle Dragoon, the 30mm vehicle. It's Crow's J on those vehicles that aren't displaced by this, and it's also an infantry carrier vehicle Scout. So their current reconnaissance vehicle, which has a long-range sensor on it, it has a manually fired machine gun. It doesn't have a remote weapon station. So we're going to displace all of those vehicles with infantry carriers with a remote weapon station and the long-range Scout sight. So it's really 3 sets in that package. Then following behind that, our double V hull A1 upgrade. That is wrapping up all its technical testing. We're going to do an operational test next fall up at Joint Base Lewis McChord. And that goes to double V hull units, so it buys back all their loss of weight, gives them mobility like the original flat-bottom Strykers had, but better protected, carrying full combat kits, and with some room for growth in the future. And then we've just started our other fleet lethality program. So we have Crow's J will go to the whole fleet, but beyond what we're doing for 2nd Cavalry Regiment, the investment in the remote weapons station is improving the sight. It's giving it some far target locate capability, and that will enable us to extend the range at which we engage with Javelin. We're making an investment in our anti-tank guided missile vehicle so it can get some more modern networked fire capability on it. And then the Army's talking about bringing 30 millimeter to the rest of the Stryker fleet. Still working through the specific requirements and timing on that, but that appears to be in the offing. So there will be a follow-on activity to what we're doing in 30 millimeter that looks at a fleet-wide solution.
And we'll be definitely sure to talk to you at AUSA for the latest update on that, because there are a couple of more questions I've got on that. But your time is tight, so I want to hit you with 2 questions. One, active protection. This has been something the Army has been thinking about for decades. I started my career in 1992 writing about active protection at the time. I know that Army scientists were working on that. You are looking at a down select decision here for the tank. Talk to us a little bit about, and one of the things that you cautioned people when we had our question and answer was, just don't believe purely in bumper stickers. You guys are in the actual analysis phase on what actual deliverable capabilities are for these systems. Talk to us in as much as you can, because I know that there's a very prominent decision pending, but talk to us a little bit about what the promise is and what the realistic expectation should be for some of these systems, because they are no panacea. Even when mounted on a tank, it's no panacea, because anybody who knows tanks knows it's like a gigantic 70-ton Swiss watch is really what a tank is.
Yeah, so it's been challenging. The U.S. Army used to be a leader in that area, and one of our challenges was we'd set very exquisite requirements. You'd fall somewhere short and then decide, well, not good enough, I'm not going forward. And at the same time, we'd decide to change which platform we were focused on putting it on, and because the platform and the system have to be relatively tightly coupled, that meant we were starting over all the time. So we took a different approach this time, and we were challenged. At the time, the acquisition military deputy came to us looking at the Army's long-term active protection system program and said, okay, that's good, we like what it's doing, but can't you give us anything faster? And we said, well, not using a traditional approach. The non-traditional approach is, let's not set a requirement. Let's evaluate existing off-the-shelf systems on our vehicles, see what they do, and then come back and ask the question, is this good enough? So normally, we could start with a requirement and build to it, and then one of the last things you do is put it on a platform. So we inverted that. So we got 3 off-the-shelf systems, Trophy, Iron Fist, Iron Curtain. Each one of them is being installed on an Army platform, Abrams Bradley Stryker. And then what we call characterized. And I use that term very specifically, both terms specifically. Installation is not integration, right? I'm not going to crack into the vehicle software to tie in the active protection system software, because if we decide, I don't want to make that investment, I've spent a lot of time and money to get that point. So let's put it on essentially as an applique, see how it works, and see what the implications are to the vehicle, right? So our characterization asks the question, one, does this off-the-shelf system perform as advertised? Lots of claims. Okay, let's see if you meet those claims. And then what are the impacts to the vehicle, right? Is it heavy? Is it power hungry? Can you really put it on? And so the thing. And
will the operator tolerate trade-offs, for example, like lower slew rate on a turret, for example, or something?
Right, yeah. So, and some of the things we're learning, depending on which system we're talking about, and to sort of preserve the vendors that are still in the characterization. I'm not going to be specific to any one of them. But some of them, they don't have a lot of shots under their system, so their confidence in hitting a range of targets varies from system to system. And unlike prior evaluation of active protection, where we kind of had a lab-like setup, right? I've got a container and I put the APS on it. No, this is on a combat vehicle. We're shooting live rounds at a live vehicle because we want to test the claims in full. And so you learn, hey, some of our vehicles don't have the power. So Bradley, we could not put an APS system on Bradley were we not doing the Bradley A4 program right now. We actually took power generation and the slip ring from the A4, put that on an A3 in order to do this evaluation, because that margin just was not there in the current version of the vehicle. You learn about weight impacts. Where is critical to put weight? right? How do you balance the sensors, right? So each one of the systems has a different sensor approach. Where do they have to be positioned? What's now in the way in the geometry of the vehicle? And how significant is that? Does that result in a degradation of the APS system's performance? Or is that, hey, now maybe I've got something in the way of a vision block that's now a concern for maneuvering the vehicle?
And each one of these are a couple of tons, right? I mean, so they're not exactly light systems that you're
Right.
putting on any of these
They're
vehicles.
all a little bit different depending on what they are. Now, in some cases, you can take off some equipment. But there's a myth out there that says, hey, if I put on active protection, all of a sudden I can design 20-ton armored vehicles. And it's just not true. Anytime you have a projectile coming in at your platform, even if you hit it, you break it up, you have residual material flying at your vehicle. You have to have some armor left to stop, whatever the APS didn't. And then, oh, by the way, there's all kinds of threats, long rod penetrators, explosively formed penetrators, that right now APS just doesn't have the ability to attack. And so you still have to defend against those for whatever your mission role is. So it's a very difficult balance to strike. And so what we're coming in on the program is to say, hey, here's what it does. Here's what we see the trade-offs are. And given that, we know we want to deploy capability, especially in Europe, very rapidly. Are the trade-offs worth it? Do we proceed on a sort of rapid procurement? Do we fix things first? What level of concurrency are you willing to buy in the system? Do I procure while I'm fixing, or do I say, hey, not that system, just too much work? That's good for the long-term program of record, because there is a program of record coming called Vehicle Protection Systems. Much broader suite of capabilities. That's not just the hard kill active protection that we're looking at now. That'll look at soft kill, hostile fire detection, a whole range of vehicular mounted protection suites. And so, right now what we're doing is something sort of not go, no-go for anyone, but better informs us and helps us make structured decisions for the future.
And you're going to have an announcement at AUSA?
We will. Come see us. We're going to actually show you some of the designs, and we'll tell you in a little more detail what we've been doing.
Let me ask you lastly about lasers. Navy has had some success. USS Ponce has a laser that's deployed. Navy has been looking at that technology, railgun technology, but combat vehicles are power limited. And the Army has wanted to put lasers out on the battlefield. Nautilus was a system, tactical high energy laser. I mean, there are a whole bunch of things that the Army has looked at as air defense revolutionary technologies, and was a laser pioneer in many respects. Talk to us a little bit about some of the challenges of putting a laser on a Stryker. You guys are trying that or experimenting with it. It is certainly an anti-drone, but also as an anti-artillery rocket mortar system, understanding the kind of stuff that the Russians are deploying against us in particular. Talk to us a little bit about the laser variant of Stryker, where you are on it, and what are the key breakthroughs that have to happen for it to become operationally useful?
So the key is you got to start with what's your operating concept. How do you want that to occur? If you're deploying a laser against what threats, and is it being used in conjunction with systems or independently? So if I want to put that on an infantry carrier where I have volume that I got to carry infantry, it's got to be very, very small volume. So I may not be able to have a high-powered system, right? So the laser Stryker that's being demonstrated right now, a mobile high-energy laser project. Oh, by the way, not my program. I'm a supporting player to that, to be perfectly honest. But pretty promising. Demonstrated 5-kilowatt laser going up to 10. And with the existing power generation on the vehicle, probably up to 15 kilowatts we can handle. Then you need to start looking at alternative technologies. You may be going to an inline starter generator that runs on high voltage rather than low voltage. That gives you more power to draw from. Or you may be having to look at, hey, do I need capacitor banks on the vehicle in order to store power so I can put out a highly powerful shot? And so when I start doing that, now I lose volume for other things. If it's a dedicated air defense or counter-rocket platform, maybe that's a good trade. But if I want it to do other things in the formation, now I have to consider exactly what I want it to do. It's been very promising against small UAVs, even at the 5-kilowatt laser level. So back to, hey, when's good enough? I'm not sure. We're watching the technology folks and the requirements folks talk about what's the right cutoff for against what kind of threat targets. I think we're probably getting close in at least that range. But if there's an expectation sometimes that, we're going to start using lasers against other tanks. Look, it's going to be a long time before we have enough power to burn a laser through rolled homogeneous armor in any amount of time. So I do think the near-term application in counter unmanned aircraft and in counter rocket artillery mortar is probably the sweet spot for Army applications in the near term.
Sir, thanks very much. Really appreciate it, and look forward to talking to you at AUSA.
Yeah, look forward to it. Thanks.